Today, as what I've mentioned here, I will bring you to a journey into the infinitesimal. So, okay, the question, what is the world and why is the world, is a question that humanity trying to search for since the beginning of the civilizations. For example, 3,000 years ago, it was the time of Abraham, right? And at the time, at the time, a lot of philosophers and scientists, we can call at the time, has already thought about these questions. And they try to approach this question in two ways. Some of them think that the world is made of atomism, and some of them think that the world can be broken down into infinitesimally small. And what are them? I'll explain them one after another. So what is atomism? Atomism is in principle the belief that the world is made of basic particles, elementary particles. At the time, you can see that here is a picture. It is actually the Middle Age chemists has been reconstructed the idea from the Greeks' time. So they consider that the world is made of basic elements, for example, smoke, fire, charcoal, water, or air, or ether, or something. But anyway, this idea has been already proposed by the philosophers in different cultures at the time. Different cultures as Chinese cultures and Indian culture and also Greece and something else. And what is the infinitesimal? The infinitesimal thought is about the thought that the world can be broken down into half and half and half and continuously. So here is a little poem which is written by a Chinese poet which is called Zhuangzi. He considered that the world can be broken down into half and half and half to continually, forever and ever. And this is a famous mathematical model, mathematical series that we have kind of solved in our modern ages. 1/2 plus 1/4 plus 1/8 and to the end. So it corresponds to a famous paradox of the Achilles and the tortoise. There is a very ancient Greek paradox who says that if Achilles is some distance behind the tortoise, he can never catch the tortoise. Why? Well, the argument is that if Achilles, he reached the distance of the tortoise will move on. And if Achilles again moves off, the tortoise will again move on, so it can never happen. But nowadays, we understand that it is actually not true, this argument, because 1/2 over 1/4 plus 1/8 to the end, it has some limit. So that is why Achilles can actually dispass the tortoise. Okay, it was at the time the philosophers thought the world was like this, and thousands years later, we come to our modern ages. And the iconic image of the atomism has changed from this to this. Some of you maybe know it is the famous satellite model of the atoms. However, atoms is actually, as far as we understand, it is still not the smallest particle of the universe. The atoms can still be divided into electrons and protons and neutrons and something else. So, when we thought about the subatomic structures, what are we thinking about? Maybe there are some words that some of you has heard about. There are particles, string theories, quantum, electrons, hadrons, muons, a lot of things. And the very center of this world puzzle is the standard model. Okay, what is the standard model? It is this. What is this? Actually, some of you, a lot of chemists here, you may know the Mendeleev table about the elements. And the standard model is exactly the same table for the subatomic structure. I mean, not exactly, but the philosophies behind is exactly the same. Okay, so let's see what are exactly the subatomic structures. We have atoms, which are kind of some very fundamental structure of the universe. It can be broken into the electrons and the heart. And the core of the atom. And the core of the atom is actually not as far as we know, not the smallest. It can still be broken down into quarks. Okay, if you want, it is like a bubble. Inside the bubble, there are some other bubbles. I take an analogy. It is like Russia dough. In the Russia dough, there is something we need to open the Russia dough to see what is inside and open that to see what is again inside. However, it is not easy to break these kind of Russia doughs. We need a lot of energy. And the approach of our modern physicists is by the collision of two particle beams. So that is why it gives birth to the accelerators. It is really a one-century exploration. At the beginning, when we have explored atom, it was already only 1880s, and the structure that we discover is 10 minus 10 meters. And again, we go to even smaller scales of the particles that we want to observe. The accelerators are becoming bigger and bigger and bigger. And now at CERN, what we use is the accelerator, the collider of 27 kilometers. However, the standard model haven't been all proved. We even need even larger accelerator to see what is even smaller particles. But the stuff is, to build a collider, it is very expensive. It is very large, and we have only one Earth. We cannot have infinite spaces. So that is why now researchers thinking about other ways to replace the conventional accelerator technologies. There are laser wake field accelerators, dielectric accelerators, or gamma-gamma colliders. And I especially talk about laser wake field accelerator because it is our subject. It is the subject that we are doing in our labs. So what we are doing is we use a laser to drive a plasma wake field, and in this plasma wake field, it can create some similar structure as the conventional accelerators to accelerate particles. And we can see that the scale of this comparable scale of the plasma wake field accelerator is only 1 millimeter, so it can significantly reduce the size of accelerators. However, these novel accelerator technologies are for the future. Okay, then I want to discuss one question. It is expensive to build these colliders. It is expensive, a lot of efforts, a lot of scientists are doing this. But why? What's the meaning of putting so much money, so much effort, so much time? And I've thought about it, and I think that for sure there are meanings. Because the first reason is for fulfilling our curiosity and for finding the meaning of the world. What's the world and why is the world? And also, it is not only has this kind of spiritual reason, it also has some very, very practical reason. Actually, it can give birth to a lot of applications that we have even not imagined. And also, for sure, it is going to fill the human knowledge basis for others to give birth to even advanced technologies. There is one little example that one of the projects that we are doing in our lab, it is using this kind of laser acceleration technology for the medical usage. For example, which are listed here are electrotherapies, proton therapies, and also better cancer imagings using this kind of technologies. So these things we haven't really imagined, for example, 20 or 30 years ago when the first guy has thought about the laser plasma accelerations. And another discussion, for example, when this guy has thought about the quantum theories, who has thought about that now we can use it into quantum computings? Okay, thank you very much for today's talk.
Thank you very much for the talk. Any questions? Yes.
So you talked about the 1 millimeter laser accelerator.
Yeah.
And can you build it into like 27 kilometers?
No, because the concepts are totally different. Actually, the 1 millimeter accelerator can do the comparable job of, for example, several kilometers accelerator, because the conventional accelerator technology is using the metal cavities, and the metals are vulnerable to electric field. If you put a so strong electric field, it can break down. But this stuff does not exist in plasma accelerators. That is why plasma accelerators can support the acceleration field 100 times or 1,000 times stronger than the conventional ones. And so we cannot build it for very long distance because plasmas are not that stable. You need to sustain plasma in some laboratory conditions. And normally we can build that for 1 meter. It is the large maximum. But as I've said, it is the future objective that we are trying to reach. So maybe in the future we can overcome this shortage.
I have a question.
Yes.
So, how long it will take to reach the next generation of the colliders?
Well, the next generation of colliders, it is not that promising that it will be maybe the laser wake field accelerator. Maybe there will be dielectric or gamma-gamma colliders or mu colliders or something else. The objective is, say, in 30 to 50 years, we will build the next generation one.
Thank you for the great talk.